Hello everyone, welcome to our channel. Today we are going to solve some numericals of miscellaneous exercises class 11 complex numbers and quadratic equations. So let's proceed. Question number 5. If z1 equal to 2 minus I and z2 equal to 1 plus I, find mod of z1 plus z2 plus 1 divided by z1 minus z2 plus 1. So here is the solution. Mod of z1 plus z2 plus 1 divided by z1 minus z2 plus 1 equal to 2 minus I plus 1 plus I plus 1 divided by 2 minus I minus of 1 plus I plus 1. After simplification, in the numerator it will become 4 and in the denominator 2 minus I minus 1 minus I plus 1. So it will become mod of 4 divided by 2 minus 2I. Now in the denominator and in the numerator we will multiply with the conjugate of 2 minus 2i. So it will become mod of 4 into 2 plus 2i divided by 2 minus 2i into 2 plus 2i equal to 8 plus 8i divided by 2 square minus 2i whole square. So I square will become minus 1, minus into minus will become plus 4. So equal to mod of 8 plus 8i divided by 4 plus 4 equal to mod of 8 plus 8i divided by 8. So it will become mod of 1 plus I. Now we know that mod of a plus ib equal to root over a square plus b square. So it will become root over 1 square plus 1 square equal to root over 2. So this is the answer. Now question number 6. If a plus ib equal to x plus I whole square by 2x square plus 1, then prove that a square plus b square equal to x square plus 1 whole square divided by 2x square plus 1 whole square. So here is the solution. A plus ib equal to x plus I whole square by 2x square plus 1. Therefore a minus ib we can write x minus I whole square divided by 2x square plus 1. Now we will multiply a plus ib into a minus ib. So it will become x plus I whole square by 2x square plus 1 into x minus I whole square by 2x square plus 1. So it will become x plus I into x minus I whole square by 2x square plus 1 whole square equals to x square minus I square. So minus I square will become plus 1. So x square plus 1 whole square divided by 2x square plus 1. Proved. Now question number 7. Let z1 equal to 2 minus I and z2 equal to minus 2 plus I. Now find real part of z1 into z2 divided by z1 bar and imaginary part of 1 by z1 into z1 bar. Now here is the solution. Z1 equal to 2 minus I, therefore z1 bar will become 2 plus I. Now z1 into z2 by z1 bar equal to 2 minus I into minus 2 plus I divided by 2 plus I. So 2 minus I into, we will take common minus, so minus of 2 minus I. So it will become minus of 2 minus I whole square divided by 2 plus I. So it will become 4 minus 4i minus 1 after simplification. So minus of 3 minus 4i by 2 plus I. Now minus of 3 minus 4i into 2 minus I divided by 2 plus I into 2 minus I. So we will multiply by the conjugate of 2 plus I. So it will become minus of 6 minus 3i minus 8i plus 4i square. It will become minus 4 divided by 2 square minus I square. To 2 square equal to 4 and I square equal to minus I square equal to minus 1. So minus into minus will become plus 1. So it will become 4 plus 1. So minus of 2 minus 11i divided by 5. So minus 2 by 5 plus 11 by 5 into I. Therefore real part of z1 into z2 by z1 bar will become minus 2 by 5. Now 1 by z1 into z1 bar equal to 1 by 2 minus I into 2 plus I. So it will become 1 by 4 plus 1 equal to 1 by 5. Therefore imaginary part of 1 by z1 into z1 bar will become 0 because there is no imaginary part. So the imaginary part is 0. Now question number 8. Find the modulus and argument of the complex number 1 plus 2i by 1 minus 3i. So let z equal to 1 plus 2i by 1 minus 3i. Now we will multiply the numerator and the denominator by the conjugate of 1 minus 3i. So it will become 1 plus 2i into 1 plus 3i divided by 1 minus 3i into 1 plus 3i equal to 1 plus 3i plus 2i plus 6i square. So it will become minus 6. Now in the denominator, 1 minus 3i into 1 plus 3i will become 1 square minus 3i whole square. So it will become 1 plus 9 equal to 5i minus 5 divided by 10. So 5i by 10 minus 5 by 10. So it will become minus 1 by 2 plus 1 by 2 into I. Now let r cos theta, where r is any positive number, equal to minus 1 by 2, and r sin theta equal to 1 by 2. Now r square cos square theta equal to 1 by 4 and r square sin square theta equal to 1 by 4. After adding, we will get r square into cos square theta plus sin square theta equal to 1 by 2. Now we know that cos square theta plus sin square theta equal to 1. Therefore, we will get r square equal to 1 by 2 or r equal to 1 by root 2. Here we have taken r as positive. So we have neglected the negative term. Minus 1 by root 2 we have neglected. Now the modulus of z equal to 1 by root 2. Now therefore r cos theta equal to minus 1 by 2. So here we will put the value of r here. So it will become 1 by root 2 into cos theta equal to minus half. Now cos theta equal to minus 1 by root 2 after simplification, and 1 by root 2 sin theta equal to 1 by 2. Therefore sin theta equal to 1 by root 2. So clearly here theta lies in the second quadrant, because we know that all sine, tan, cos, this formula. In the second quadrant, sine is positive and cos theta is negative. Now here theta will become pi by 4, that is 45 degree. Here is the picture. Here this complex numbers are equal to minus 1 by 2 plus I into 1 by 2. It will like this. So this is the angle theta. Now we know that argument is the value of angle of the positive with a positive real axis by the complex number. So it will become the whole angle is pi minus this angle theta. So it will become pi minus theta. So pi minus theta will be the argument of z. Therefore argument of z equal to pi minus theta. Pi minus theta here is pi by 4. So it will become 3 pi by 4. Therefore argument of z is 3 pi by 4. Now next question number 9. Find the real numbers x and y if x minus iy into 3 plus 5y is the conjugate of minus 6 minus 24i. So here is a solution. Given x minus iy into 3 plus 5y equal to conjugate of minus 6 minus 24i. Therefore x minus iy into 3 plus 5y equal to minus 6 plus 24i. Or now we have multiplied it, 3x plus I into 5x minus 3iy minus 5 I square into y. So it will become plus 5y equal to minus 6 plus 24i, or 3x plus 5y plus I into 5x minus 3y equal to minus 6 plus 24i. So after comparing on the both sides, we will get 3x plus 5y equal to minus 6 and 5x minus 3y equal to 24. Now 3x plus 5y equal to minus 6. So 5y equal to minus 6 minus 3x, or y equal to minus 6 minus 3x by 5. Now 5x minus 3y equal to 24. So 5x minus 3 into y, we will put the value of y here. So it will become minus 6 minus 3x by 5 equal to 24. Or after calculation, it will become 25x plus 18 plus 9x divided by 5 equal to 24. Or 34x plus 18 by 5 equal to 24. Or 34x plus 18 equal to 120. Or 34x equal to 120 minus 18. Or 34x equal to 102. Or x equal to 102 by 34. So x equal to 3. From the first equation, now we have y equal to minus 6 minus 3x by 5. So it will become minus 6 minus 3 into, here we will put the value of x into 3. So it will become minus 15 by 5. It will become minus 3. So x equal to 3 and y equals to minus 3. This is the solution. Now question number 10. Find the modulus 1 plus I by 1 minus I minus 1 minus I by 1 plus I. So 1 plus I by 1 minus I minus 1 minus I by 1 plus